Aloha and welcome to this part of the web application development module. In this part, I'm going to be talking about model development, and I'm really excited about this model. I think that we are embarking on this process of enabling you to put together web applications in a lightning fast manner, and I think you're going to be really excited to have these tools at your disposal. When we talk about models, what we're talking about is 1/3 of the primary architecture of almost all web applications. Pretty much the basic way that modern web applications are put together is using this design pattern or architecture called MVC, Model View Controller. And the notion here is that you split up the processing according to 3 different responsibilities. You're going to have a controller. That part of your system is responsible for getting the HTTP request from a browser, figuring out what to do with it, and passing the results back. Okay? So that's in the Play framework. You're going to be using the routes file to specify how you map the HTTP requests onto various action methods that you define, and then you'll implement those action methods in the controllers package. The view package contains a bunch of templates that enable you to design how the information given to the user is going to be presented. Okay, and in Play you have a bunch of files that have the suffix .scala.html. That's because they're Scala templates, or actually Scala classes, and we can also use any modern CSS or HTML5 framework as part of the view. So for example, next week we'll probably be going into the view section and we'll be using Twitter Bootstrap, which is maybe the most popular kind of faddish HTML5 CSS framework in use right now. I like it. It's really fun to use. Okay, but today we're not going to talk about the controller, we're not going to talk about the view, we're going to talk about the model. And the model is the part of the program where you define your domain representation, and you typically, by convention in the Play framework, you're going to put that in the models package. And then what we're going to show you is how we're going to make that model persistent, which is obviously a crucial part of any functional web application. You need to be able to bring the system down and not lose all your data. So there's the way we're going to do that in this class is by using an object relational mapper called eBeam, and then interface it to some back-end relational database. So I'm showing you here there's several alternatives. There's H2, which is this kind of built-in database provided by Play, and we can also hook it up to a MySQL system or Postgres and a variety of others. So that's the MVC architecture, and we're going to go through each of those components in turn over the next 3 weeks. So the model, it's basically just a representation of whatever you're trying to display in your web application or manipulate in your web application. And it's going to be implemented as a set of Java classes, and you'll typically try to design your model, at least at the top level, in terms of objects and relationships among them. Okay, so as you think about what your web application should do, you have to make sure that your model is sophisticated enough to enable you to answer any question the user might ask of your application. So when you're developing a model, there's really 2 big questions. One is, how do you design this representation such that you can provide all the information the user might want to have? That's a super hard problem. We're not going to really deal too much with that actually in this class right now. We're going to kind of just give you problem descriptions and let you stumble through the iterative process of coming up with a decent model. The second hard thing is making this model persistent. And the reason why that's hard is because there's several different approaches to doing it, all with different kinds of trade-offs. One approach to making it persistent is to use a back-end relational database. And these are all the databases that you're familiar with: MySQL, Postgres, Oracle. They've been around a long time. They have a nice mathematical foundation. There's been a lot of research done on them to try to make them be efficient with respect to space, efficient with respect to queries, and so forth. But there's a huge problem with these relational databases, which is that this table-based approach or representation in these databases does not map well to your typical object-oriented domain model that you'd have kind of in your system. And this problem has been termed the object relational impedance mismatch. And I've put a link on in the reading so you can learn a little bit more about that. And it's just something kind of fundamental to trying to map a bunch of objects into a bunch of tables. It's a round peg in a square hole kind of problem. So some folks have, for a number of years, been trying to get rid of the object relational impedance mismatch and all the problems that creates, some of which you're going to encounter as you start to use this, this mapping approach. They've come up with object-oriented databases where they say, why bother to map these things to a bunch of tables? They're objects. Why don't we just persist the objects and persist all the links between the objects? And so there have been a variety of mostly experimental systems developed, although there's some commercial systems that are purely object-oriented databases. And they solve the impedance mismatch problem because there's no mismatch anymore. You have objects in memory in your program, and you also have objects on the database. For reasons that are not entirely clear to me, object-oriented databases are not that popular. They're not used that much, and it might just be the fact that relational databases have such an entrenched market share and people are so familiar with them, and they've worked with them for such a long time, and they understand the problems that with them so well that they're unwilling to kind of, break ranks for this object-oriented database paradigm where there may be new problems and there are problems that they don't understand well yet. However, interestingly enough, in the past, I'd say 3 to 4 years, there have been a new set of databases that have been developed and they call them NoSQL databases or persistent stores. And the idea there is that you're basically persisting a bunch of key value pairs. And there are certain situations in which that creates a much more scalable type of persistent store, and with much more performant characteristics than trying to map essentially unstructured data into this relational paradigm. Google is a big proponent of the NoSQL approach, and they've gotten a lot of press, and you can read about NoSQL to learn more about this alternative. In this class, however, the way we're going to deal with it is we're going to do basically what the Play environment supports right out of the box, which is to use an object relational mapper to take our Java classes and persist them in a table-based relational database. And it doesn't completely address the object relational impedance mismatch, but it makes life a little more convenient than it would be otherwise. So when you have an ORM, what you basically have is a language that allows you to specify in basically a declarative way which of your classes are going to be persisted as tables, as basically rows in a tables. And then you're going to specify the fields and how they become columns in a given table. And then you're going to be able to specify declaratively whether a relationship between two entities is one-to-one, one-to-many, many-to-one, or many-to-many. Okay? Lots of other stuff that you can do in a mapping system, but for this kind of beginner level that we're at, let's just focus on those characteristics because they're the primary ones. And if you can get those down, then there's lots of other kind of parameters you can add to customize the way the mapping occurs, and they're easier to understand once you have these together. So once you've kind of annotated your Java classes with this specification of how it maps to the relational database, then these ORMs also provide convenient utility methods that enable you to persist objects out into memory or query the database and for certain kinds of objects that satisfy criteria, and then the system itself will do the SQL query, get the rows out of the database, and then construct the objects for you and give them back to you. So basically, when you're using an ORM, you're basically programming in Java and not worrying too much about tables. You're creating Java objects, and then you're persisting them, and then you're doing a query on your persistent store, looking for objects with certain kind of characteristics, and you get them back. So it's pretty nice. The one we're going to use in this class is called eBean. It's an open source Java-based object relational mapper. It uses JPA annotations at entity, at one-to-one, etc., which is pretty much the standard that all the popular ORMs use. It has support for the backend database, most of the currently popular backend databases, so you don't have to worry about that. It's got this crazy feature called automatic query tuning. I haven't played around with it much, but basically it can profile the queries that you're making and figure out when you do a query what fields you actually need, and then kind of tune your query to reduce the amount of data or speed up the process for you. And I've been looking in some of the groups associated with eBean, and people really like this feature. Apparently, it can really improve the performance of your system without you really doing anything more than just running your program on some typical data. And finally, this is the ORM that's provided by default with the Play framework. So there's decent documentation for it and so forth. So here's an example of how it looks. You can see that we have this basic Java task, and we're going to extend. We're going to extend the play.dbean.ebean model class. Okay, so that's one important thing, and that's going to provide some kind of nice, the superclass is going to implement some nice methods that we can use. And then we're going to use these annotations at entity, at ID, and at required in order to to tell the object relational manager the fact that this particular Java class should be a table in the database, and that this should be the primary key associated with each instance of this task class, that the label is required, and so on and so forth. Here's the declaration of a method called find, or in this case it's just a static instance variable called find, which can be used to construct queries to obtain task instances from the database. Okay, so that's kind of how that looks. We're going to go into a lot more detail on that in my next screencast, but I wanted to give you kind of a general sense for how things are. So there's basically three ways there's a three-step process to designing the model part of your model view controller. And what's cool about designing the model is you can really do this, at least initially, in the complete absence of a controller and the complete absence of any views. So you can kind of sit down with your problem specification for your web app, sketch out what your model is, and just implement the darn thing without even worrying about anything else. And in fact, that's what I'm going to show you in the next screencast. Is I just created a default Play application, the Hello World application, and then implemented the model inside that, and didn't worry about the controller or what the views looked like or anything. So what I suggest you do is you start by creating a very, very simple data model diagram, just to specify what the entities are in your system and what the relationships between the entities are in your system, and you get that from the problem specification in somewhere, and that can provide nice documentation for the structure of your system, so that people can easily see what are the entities and what's going on there. There turns out to be a free plugin to Google Docs called Lucidchart, which has drawing tools for making entity relationship diagrams, which I discovered, and so I want to strongly recommend. In fact, I'm going to have you use this tool for the assignment, so that you get some familiarity with just making these diagrams. They're super simple. And you're going to specify, as I said before, the relationships between their entities, whether they're one-to-one, one-to-many, and so forth. Once you've got your simple data model diagram, the second step is to go into the models package, probably creating the models package, because it turns out that when you say play new, foo or new application, it doesn't actually create the models package for you, which is basically because the Hello World application doesn't have a model associated with it. So anyway, you're going to create the models package, and then you're going to define a Java class for every entity that you've created in step 1, and you're going to create fields for each of the relationships that you've defined in step 1. And then you can go from there right to developing a JUnit test in the test package that's going to verify that your model is consistent and actually works the way you need it to. And that JUnit test, again, is going to be very simple. You'll basically create instances of each of your entities. You'll create all the relationships between the entities in Java, so you'll set the fields up so that everybody's related to each other in whatever way you're specifying. And then you'll just persist everything out to the database, and then you'll do queries on the database to get all those objects recreated from the database, and then you'll just check to make sure that all the entities are there, and that all the relationships are still there, and that you didn't get any runtime errors. And as long as all those things are the case, now you've got a model that's consistent and does what you need it to do, and you can go on with designing the rest of your system. Okay, so I have put together a page with some of the heuristics that I've come across for model development, and I'll switch to that now. Okay, so if we go over here, I have a link to this in the assignment. I'm just going to go over it real quick now. I'll probably also come back to it in the next screencast where we'll go through all of these things in more detail, but I wanted to kind of quickly go through it to give you a sense for what's happening. The first thing is that by default, the eBean object relational mapper is not enabled in the Hello World default play application. So if you're starting from that, which is the way you usually will, the first thing you have to do is go into the application.conf file and uncomment these db.default things. And then also, what I recommend is that you add this particular property right in the evolution section, which is apply evolutions.default equals true. This means that as you're fiddling around with your with your entities and your relationships and so forth, that you're giving permission to the object relational mapper to go ahead and edit the schemas appropriately, so that the database will work. The underlying database structure will be consistent with your top-level Java classes, which is, of course, how you have to have it. By having it do it automatically, that saves you having to tell it that it has permission to do it. The only cost to that is the fact that sometimes, depending upon the kinds of changes you're making, you might lose data. Now, during development, since you're not really trying to create data that you need permanently anyway, this is no big deal to lose data. Once you go into production, of course, you do care about maybe losing data, and so you'll want to kind of comment this out when you move to production. But during development, it just makes life a lot easier, because the system is going to take care of changing the schemas as you develop your model. Second thing, as I said before, use Lucidchart. Here's the link to it. And here's an example of a nice little ER diagram that I created. This actually corresponds to the sample model that I'll be showing you in the next screencast. And you see we've got a warehouse, we've got a stock item, we've got a product, and we've got a tag. The fields, I don't bother to specify all of the fields associated with these classes. The main thing is I just have the name of the entity, and then whether it's a many-to-many, many-to-one, or one-to-many relationship. Okay, that's the key thing you want to kind of see. So here you can see that we have a warehouse, and one warehouse can have many stock items in it. Each stock item, there can be a single product can be associated with many stock items, but each stock item is associated with only one product. And then a product can be associated with multiple tags, and multiple tags and a single tag can be associated with multiple products. Okay, and you can see here when I use it, basically I have a little yellow comment that just says in English what the meaning of the crow's nest notation is, just to make it a little clearer. Okay, so as I developed this, I came up with some hints that I think will make it easier for you to, avoid problems when you're developing your basic 3-tier web app. I think this is a good way to start. It doesn't necessarily create an optimal system from a performance perspective. There may be some scalability or retrieval issues associated with it, but it does kind of prevent some difficulties from occurring. So I recommend you start out this way. If your system turns out at some point, at some level of usage to be slow, then you can start profiling it and see actually what part of the system you want to try to fix. So here are some of the things. You should always be extending the play.db.ebeam.model class and have any classes that you want to be persisted annotated with @entity. That's not really a heuristic, that's just basically a rule. The second thing, which is also a rule but is can kind of be a gotcha, is the fact that you can't name a class with an SQL reserved word, okay, and have things work okay. So you can't have a class called catalog or a class called group or a class called user. Okay, that's not going to work, right? Even though user is kind of a really common name of a table or of a class that you might want to have in a system. What you can do is either you can name it something different, or there is a JPA annotation where you can specify, even though my class name is user, I want my table to be actually named something a little different. Okay, so you can get around it, but I just want to kind of raise the flag to you right now that you've got to worry about this, because if you inadvertently name it output, you can get this kind of strange error that's a little difficult to understand. The third thing, and this is something I think makes it easier to make sure your model works correctly, but can result potentially in performance problems, is to make all relationships bidirectional. So that means that when you have a relationship between two entities, there is a field in each entity that will point back to the other entity that has a relationship. Okay, now strictly speaking, you don't have to have relationships be bidirectional. You could just have the relationship be available in one of the entities and not in the other. But by making it bidirectional, it just makes things cleaner, and potential problems with the model become clearer to you earlier. So I want to say in this class, make all the relationships bidirectional. The performance overhead is not real big. And actually in some cases having the backlink can actually make things more performant depending on what you're kind of doing. Okay, because we're having all relationships be bidirectional, so we have things going back and forth. We have to have an owning entity, which is the entity whose corresponding table is actually going to have a column indicating the foreign key of this other entity involved in the relationship. And the basic way that you do this is when you have a many-to-one field in an entity, that's the table that's going to own that relationship. And so the way that you specify to the ORM that that's where you want the column to appear is that in the other entity, which is going to have @1-to-many, right, since the first one has @many-to-one, you're going to provide a mapped by parameter which specifies the field in the first entity where the column should appear. It sounds a little complicated. It is a little complicated first, and then it becomes pretty obvious. And in the next screencast, I'm going to show you an example of several examples of this, so you can kind of get it together. But the point is, with a bidirectional relationship, you're going to always have to have this map by parameter someplace to specify where the column is. When you have a @1-to-one relationship, that means there's you have two entities. They both relate to each other. They're both going to have a field cross-referencing each other. Same thing. You're going to have a map by parameter to specify which of these entities actually has a column with a foreign key to the other entity. And in the @1-to-one, you just pick one of them according to whatever you want. Finally, there's this mechanism in ORMs called cascading. The idea there is that if you're persisting an object and then it's looking in one of these fields that has a relationship and it finds a Java class instance that has not yet been persisted, okay, that it will just automatically go ahead and persist that entity for you without you having to do it explicitly, so that it can get a primary key for that particular entity and then go ahead and and use that in the column. If you don't have cascading, then you've got to manually make sure that every entity is persisted before it can be referenced in a relationship, and that's just kind of painful and leads to a lot of code, a lot of save calls that you'd really prefer not to have to do. So if you put this provide cascade equal cascade type all as a parameter in your relationships, then you should be good. Okay, it's going to go ahead and it's going to do these implicit creations when you need. For querying, the eBean ORM provides this finder class, and it's convenient to, in each of your entity classes, okay, so let's say we have an entity class called foo. What we're going to do is we're going to define a method called find. It's a static method that's going to return a new instance of this eBean finder object where it's been parameterized with a long and an instance of this foo class, or the pointer to the foo class definition. Once you have that, then you've got this pretty nice way of doing querying. Okay, so for example, if you've got this foo entity, so there's a bunch of foos in your system, and you want to get a list that has all of the foos that you've created so far, what you do is you call this static find method, okay, that we've just created here, okay, and we invoke it. We invoke the FindList method of that finder class instance, and that's going to return a list of all the foos that are currently defined in the system. Okay, it's kind of a select star type situation. Okay, let's say we had the primary key associated with one of our instances, and we want to retrieve that particular object from the database. Then again, we call our find method, and we use this by ID method, and then pass in the primary key, making sure that it's long, and we get it out there. And then there's this kind of nice chaining technique that's implemented in the find API. So if you have some more complicated query, what you do is you call the find method, and then you chain it together with this where method, and then you can say that the order date is going to be greater than or equal to last week. I'm not this last week, I've defined someplace else. And then we can specify the ordering by which we want these foo objects to be returned, and we can specify the maximum number of these foos that we want to get back. And then we end it all with this find list method, which says execute the query. Okay, so you can kind of see the SQL in there, right? How we're creating a SQL statement, but we're doing it in a more Java-esque way. Okay, you can look at the find documentation for the eBean ORM and the finder class definition, and see all the different possible methods that you can invoke on this thing. Okay. So remember, we've created our picture in Lucid Charts that gives us a sense for our entities and the relationships. Then we've implemented a bunch of classes. The final step is to create a JUnit test case, which makes sure that our model looks the right way, or that our model behaves in the correct way, that we can persist things, that we can retrieve things, that all the relationships are appropriate. And so what I wanted to do is give you the kind of the boilerplate code that you would include to create one of these model test classes. And basically what I'm just showing you is that consists of three methods in this case. We have our actual test method, the test model, and you put all your test code here, okay, in this example. And then we're going to have a before method and an after method. These are JUnit annotations, which says before each of your @test methods, execute this code, and then after each of your test methods, invoke this code. And what this is essentially doing is saying before you're going to start up a new kind of fake play application with an in-memory database, which will be fresh. There'll be no data in it, and that will be started up before each of these test methods are invoked, and then afterwards we'll stop the application and destroy everything. So this is a way of basically starting up the eBean ORM and making sure it has its default database and all the junk that it has to do before you actually run your test code. And again, in the next screencast I'll show you examples of how this works and show you what the body of this looks like. But I wanted to put into this page the code snippet, so you can just cut and paste this into your test class, hopefully you'll call it model test, and then you'll be all ready to start doing your test case development. Okay, that's about everything I have here. Enjoy learning about ORMs and data models. I think this is kind of a really fun part of the class, and I'll see you in the next screencast.